Morning. My name is Akshita Bhaskar, and today we're going to be learning about agentic protocols. Especially, we're going to see what is MCP, A2P, and NLWeb. Basically, in this lecture, we are going to describe how AI agents communicate with the world between themselves and the internet. So, we will start this lecture by defining AI agents. We will define what AI agents are in the first place and why agentic protocols are needed. And then we will go on to define the three different protocols. After that, we will have a case study and we will also look at the governance mechanism of these agents. So, let's start. A lot of people get confused between an agent and an LLM. Let's understand the basic difference. We all know that LLM stands for large language model. And a large language model is like a language brain. It has been trained on a limited set of data and it only recalls information from what it has been trained. Like your brain remembers facts, and you can only recall information from the facts and memories you have in your brain. You can't create new memories or new information unless you learn them first. But an agent is a complete decision making system which sits on top of an LLM and uses that LLM as a base to make decisions. Agents are autonomous, they have memory, they remember context, and they can be trained on feedback. Depending upon positive or negative feedback, agents can be trained and we can tell them to act in a certain way. So, agents are a more specialized form of an AI work tool that is more easily deployable in offices and environments and is usually deployed to solve a problem. And agents have more use cases. So, let's see how the world has been changed with agents. Now, in this lecture, we're going to see how this AI agent that we have developed, when it talks to other agents, this protocol becomes A to A. When this AI agent talks to the internet, this protocol becomes NLWeb. And when this AI agent talks to structured data sources like PDFs, documents, and files, this AI protocol is known as MCP. So, by defining agentic protocols, we are talking about the communication framework which agents use to sense information around them, to gather data around them. The biggest problem we're trying to solve is of limited knowledge faced by agents, because usually you deploy an agent in a company and tomorrow your requirement changes, your data changes, you have new files, you have new documents, and at that point, if you start training your model from scratch, it will take a lot of time. And by the time that problem you need to solve won't be solved. So, by implementing agentic protocols, we solve the problem of an AI agent's limited knowledge base. The biggest problem we're trying to solve is the amount of data the agent can absorb to carry out a task. Now, it doesn't matter this agent picks up knowledge from the internet, from data sources, or other agents. We are basically increasing the load capacity or the thinking capacity, the knowledge base of the agent, so it can work in a more integrated and complex environment. I hope you've got the point. Now, let's see why protocols are needed. So, as I said, that as LLMs get more complex and agent usage grows and they are being deployed more rapidly, security, interoperability, and innovation become the key parameters to which agentic protocols are needed. And right now, we're in a race against time to launch agentic AI protocols. If you have an AI agent talking to other AI agents, this protocol is known as A2A. If you have an AI agent talking to other structured data sources, it's known as MCP. If you have an AI agent talking to the internet, this protocol is known as NLWeb. So, you have AI agents in three different formats. And if you think about it, these agent launches are very recent. They just came about in 2024 and 2025. So, with that, let's start with our first protocol. Our first protocol, which we're going to look at, is MCP, which is the Model Context Protocol. And MCP is a protocol that uses data, like different structured data sources, and you basically have one MCP protocol, and you connect all your data to an MCP protocol, and your agent can absorb the information. So basically, imagine MCP as like a USB plug. You just plug any kind of structured data set to this USB, and your agent, starts remembering context. So MCP was proposed by Anthropic in 2024, and the chief problem it is solving is of different structured data sets being able to pass their information to the agent or to the LLM, because the agent is running on an LLM, and by this protocol, in fact, we're just expanding the LLM's capacity so that the agent can make more profound decisions. And but the only thing here is that it doesn't matter if you have a PDF or you have a Google Calendar or you have a video or image context file. Your file needs to be in a certain structure, and that structure is known as JSON. So before implementing any kind of MCP, you will take your file and you will push it through like a Python script that converts the information as a structured JSON format, and then you'll be able to use MCP. So the MCP operates on a typical client server architecture. You have a host, client, and you have servers. The host and client are within the app, and then you have APIs, which are the server that connect to a remote data source. I think the biggest advantage we have discussed is that if you had to train a model from scratch, it would take time. And for each structured data source, you would go on to build an API. But with MCP, you just take everything, connect it to one API, and boom, you have your LLM ready. So the biggest benefit is standardized integration. You can integrate anything at any time. It's modular and reusable. Whatever code you write for MCP, it just needs to be replicated for the different data sets by just changing the directory path. Rest of the code stays the same. It's secure and private because no actual data is being transmitted. It's just the credentials that are going, and using this you can communicate between any structured data source. So I think MCP is a very big boon to the world of LLMs. Now let's look at another agentic protocol known as A2A. So A2A is an agentic protocol that enables communication and collaboration between different AI agents. A2A connects AI agents across different organizations, environments to complete a shared task. And A2A was very recent. It was proposed by Google in 2025. And as you see that I have one main agent, and I have three other agents that are helping me do a task, so I just use A2A to connect it. And using this, I have a very complex ecosystem, and in my complex ecosystem which you see here, if I replicate this, so this is my very complex ecosystem, and if you see this part is my very complex ecosystem, and as you see here, in a small amount of time I've got 4 agents communicating to each other to do one task. So it's basically helping the AI ecosystem expand, and it's also very recent. It was proposed by Google in 2025. Now let's look at the core components of A2A. The core components include an agent card. So every agent comes with an ID card that tells about the tasks, endpoint, and authentication requirements it's needed to carry out. You have an agent executor, which is passing the context to the user chat. You have an artifact, which is the tangible output generated by the user, and you have an event queue. You see that all these agents are communicating between each other. So they won't just communicate in thin air. They are communicating using synchronous messages that are handled in a buffer queue. So here I have a simple example of an AI assistant. So maybe you go to your AI assistant to ask for something, and then you have a flight booking, a hotel reservation, currency conversion, and local tour within that A2A. So now let's look at another example, which is our natural language web. I think the problem the world is suffering now is the plethora of information. So, by looking at this slide and example, I want you to take 2 minutes to think that why would you need NLWeb in the first place? And I mean, by just looking at this picture, you don't have to read whatever is written. I just want you to think about why we would need, and I will give you 2 minutes to think. Okay, so the 2 minutes are over. Please type your responses in the chat, and let's check out what you're saying. Okay, so thank you for your responses. I think the problem we are suffering right now in the world is the exodus of information. I mean, Amazon, Flipkart, YouTube, the world is exploding with information. You go on Amazon, you want to buy a simple red t-shirt for your friend as a birthday gift in a like 1000 to 1500 rupee budget, and you are given 3000 search results, and you spend like 45 minutes scrolling through Amazon just to find one red shirt. And if you had to buy 20-30 items on Amazon, you would be wasting maybe your entire day. It depends on the item you want to buy. Like if it's a gift, you would spend more time in thinking what it is to buy. So NLWeb in a way simplifies that. So using NLWeb, you let your agent communicate with Amazon's website. So rather than like scrolling the website, you tell the agent, I want a red shirt for my friend. He is a boy, for his birthday. My budget is 2000 rupees. I want the shipping to be done in 3 days. Give me the best option. So your agent will say, based on your input requirements, here are the 3 options. Okay? So NLWeb is a protocol that basically helps you to talk to the internet in a condensed manner. You could just say ChatGPT integrated Amazon or Flipkart or Deliveroo, whatever app. Now I want you to think about what is the biggest problem we could have with this. What is the biggest cause of concern here? Okay, so you've got NLWeb to talk to the internet, but what is the biggest cause of concern here? Please type your answers in the chat. I'll give you 2 minutes to answer. Okay, 2 minutes are up, and let's see your answers. I think the biggest cause of concern is bias, because the quality of the agent depends upon the data you train it. It depends upon the reviews on the internet. It depends upon what kind of information this bot is reading, and most likely you're going to get biased or skewed responses. So even though NLWeb simplifies your experience of condensing information on the web, the response depends on how good you train the model and how unbiased the information remains. Right. So the core components of an A2A include the web app from which we're going to scrape the data, It includes the NLWeb protocol, which fetches data from this app. It includes an MCP server, which is integrated into this into the app to allow the data to be fetched and scraped from the website. Because like in MCP, you're basically extracting information from a structured data set. So even here, you're extracting information from a structured data set, because in 90% of the cases, these websites are images, texts, or video, and that's what NLWeb is for. Now, the data you've extracted is so much in volume that it needs to be condensed to an embedding model, which needs to be converted to a vector database. And for those who don't know what are embeddings and vector databases, so just embeddings are a form to take the information and convert them to their vector representation, like 1010 numerical representation. I think it looks like this. And the database that houses all these embeddings is known as a vector database. That vector database will have information stored in its vector representation. And the AI is running on an embedding and vector database revolution. So that's about it. Now, before I go forward, I want you to imagine a use study where you could use A to A, MCP, and NLWeb integrated together. I will give you 2 minutes before I show you a case study of my own. And I want you to be creative with the ideas, like where would you deploy this in an organization? And then, like, what use case would it be? And why would you do so? I can break you up into breakup rooms, and you can join in teams of 4, which will be assigned automatically, and then we could discuss the answer. I'll give you 5 minutes for this activity. Okay, your 5 minutes are over. Let's see. So one of the biggest use cases is a travel booking system. Suppose you have a user and there's a master agent, and you've been given a lot of pamphlets from Make My Trip, Ease My Trip, some websites. So you upload your data manually to this agent using an MCP connection. So the data master agent is trained with this. Now you have multiple websites. You use NLWeb to scrape the websites and get the most condensed information. And you have other specialized third-party LLMs, which are agents, and you use your A2A protocol to talk to those agents. So basically, using this, you build a very beautiful, but at the same time, a self-learning agentic system that is capable of picking up information from flights, weather, the news, the geographical updates, the visa requirements, any changes in currency on its own for you, and gives you information in a tip. So generally, in cases we've discussed, MCP is used to update knowledge through multiple data sources. NLWeb is used to scrape knowledge from internet, and A2A is used to retrieve information from other agents. Now, the most crucial aspect of our journey is the governance mechanism. Because we are handling data, data has a price to pay. If this data belongs to the company, it needs to stay within the company's servers. And here, this is where compliance comes into play. So depending upon where you are, you have GDPR or ISO rules as such. And also, data theft is a huge issue. So you need to ensure the data you give is licensed, authenticated, and trained on your own servers. as you're playing with AI agents and AI, you need to also have some kind of role based access control, some kind of IAM. So you have OAuth, API keys, and tokens in place to verify the identity and enforced control. And also because you don't want token bondage, you don't want token overuse. So you put some kind of rate limiting mechanism that at one time, like 3 APIs can be fetched, or 4 APIs can be fetched, or 2 documents can be read, or 10 documents can be read. You don't push your agent to read the internet infinitely, or you don't push your agent to read 500 documents at once. You need to put some kind of rate limiting and quota to prevent excess energy usage. These are just a few, but if you have more, please type them in the chat and let's see how they are. Okay, so thank you for giving your answers, and you're right. From the chat, I see another concern is the biased, skewed data. Maybe some companies training the model to give their results for a response. And similarly, we could have the question of energy usage, token usage, tokens being burned. Yeah, these are all factors to consider, but at the same time you have to remember that as the world gets more complex, as AI use cases become the new norm, we need to design new technologies and systems in place to keep up with the new demand of data and to keep up with the new user requirement that has come up. And agentic protocols are solving exactly that. Thank you, and I hope you've learned a lot today.